What is up, math superstars? In this edition of Mr. Peterson Presents, I'm bringing to you Objective 7.15, Solving One-Step Inequalities. And so this video is in two parts here. Our first part is we will actually solve one-step inequalities, and our second part here is we're going to graph the solutions on a number line. So now we're going to give you the steps on how to solve for addition and subtraction of inequalities here. And so this is problem number 6 on your worksheet packet. Here we have 7 plus x is greater than or equal to 9. And so just like we do for equations, we need to get x by itself on one side and our constant on the other side. So what we do for this is, since we have 7, we're going to subtract 7 from both sides of our equation, or inequality, excuse me. And that's going to leave us with x is greater than or equal to 2. And so now we're able to graph this on our number line below. And so we're going to go ahead and find positive 2. And since it's greater than or equal to, we're going to do a closed circle on 2. And our line is, our arrow is going to be pointing right. And what that tells us is that the solution sets for this inequality here, so it can be 2 would work for this. So if we filled in 2 for x, we'd have 7 plus 2 is greater than or equal to 9, so that would work. We would have 3. So if we filled that in for x, 7 plus 3 equals 10. So we know that 10 is greater than or equal to 9. And then we do 4, and then it goes on forever and ever. And so we can check our solution set with our graph at the bottom. We know that we have graphed x is greater than or equal to positive 2 properly. So now let's go ahead and try an example of subtraction now. So we have negative 5 is less than or equal to x minus 6. And so just like we did in our first inequality, we have to get x by itself. So in order to do that, let's go ahead and add 6 to both sides of our inequality. So now we have x on one side, we bring our sign down, and then we have negative 5 and a positive 6. That equals positive 1. So right now, in doing this, we have x is greater than or equal to 1. So now we're able to graph this on our number line here. And so we're going to graph it at positive 1. And we're going to go ahead and draw our line to the right here. And now, before we stop our awesome subtraction of inequalities here, we need to come up with our solution set. So with our solution set, we know that since this is greater than or equal to 1 here, so let's go ahead and put positive 1 back into our inequality to see if this works. So we have negative 5 is less than or equal to, if we put in 1 back in, so 1 minus 6 is negative 5. So we know that positive 1 works. So now let's go ahead and try a positive 2 here. So if we put positive 2 in, so negative 5 is less than or equal to 2 minus 6 is negative 4. So if we go ahead and write that out, so we can see this better here. Negative 5 is less than or equal to, so we did 2 minus 6, so that's negative 4. So we know that negative 5 is less than or equal to negative 4. So 2 works. So we can continue the pattern here. So 3 would work. We do our 3 dots because it goes on forever. So we know that our solution set checks out with our graph below. So if your graph does not match with your solution set, that means you graph this inequality incorrectly. We need to check our work. Now we have multiplication and division of inequalities here. And so in doing this here, what we have to do is, since this is multiplication, we need to get x by itself. So what we're going to do is we're going to go ahead and divide both sides by 5. This gives us x is less than -8. And so we can go ahead and graph that on a number line here. So we're going to go ahead and draw out our number line. So -8 in the middle, -7, -6, -9, and -10 to the left. Since this is less than, this is going to give us an open circle on -8. And our line is going to go to the left here. And our last step here is we're going to come up with a solution set for this inequality here. So to check this, so since it's an open circle on -8, we cannot include that into our solution set. So let's go ahead and check -9. So with -9, so we have 5 times -9 is -45 is less than -40. So this checks out. So let's go ahead and try -10. So 5 times -10 is -50 is less than -40. So that checks out. Let's go try -11. 5 times -11 is -55 is less than -40. So this checks out. So we can see we're building out our solution set here. We know that this solution set, -9, -10, -11, it goes on forever until -infinity. But we're just going to write 3 numbers, otherwise we'd run out of room. So now here we have a special case here where we need to multiply both sides by a negative number. So since this is an inequality, when we do this, we need to go ahead and reverse the sign of our inequality here. So let's see how this works. So what we're going to do is we're going to go ahead and multiply both sides of our equation by -4. So it leaves us with x and then -12. And we take our inequality here, our symbol, and we reverse it. So we can say x is less than or equal to -12. So we go ahead and draw out our number line here. So we have -12 in the middle. To the right, we have -11, -10. To the left, we have -13 and -14. So what we can do here, since this is less than or equal to -12, we put a closed circle on -12, and our line is going now to the left. And so in order to just check this, let's come up with a solution set here for our inequality. So in our inequality, so we can start -12. So let's go ahead and put that in for x. So we have -12 divided by -4 is greater than or equal to +3. So we know that -12 divided by -4 gives us a +3. So we know that 3 is greater than or equal to 3. So we say that -12 is part of our solution set. So -12 checks out. So now let's go ahead and pick a nice round number just for the sake of this video here. So let's go ahead and try -20. So we know that if this number line continues, we do -15, -16, and so on and so forth. But actually, let's try -16 because this would be a nice round number to use. So let's go and try -16 divided, we put in -16 for x, divided by -4 is greater than or equal to 3. So -16 divided by -4 gives us a +4. It's greater than or equal to 3. So -16 checks out in our solution set here. So, but for the sake of this video, we gave a nice round number, but for our solution set, we include -13, -14, and the dots continue on forever and ever here. So if we did -13, we'd end up with a nice easy decimal here. But for the sake of the video, we were just looking for whole numbers. And so So we can see that reversing our sign is going to give us the correct solution set. So this works when we have to multiply or divide by a negative number.